Hey class, I hope everybody's enjoying the sun today. So a few people have started emailing me as I asked, which is great, about a couple homework problems, and so I'm going to make you guys a couple videos. First I'm going to start off with a short video about problem 59. This is one of my favorite problems. It's really tricky in some ways, but it's a good way to conceptualize some of our forces. So on problem 59 here, you can see we're told that we have a monkey, a 13 kilogram monkey for some people, or 15 or whatever, and then a crate of some mass. Alright, and we're asked to determine some interesting things. We're determined how much upward or forward acceleration, so acceleration up the rope here, the monkey needs to have in order to lift the crate off the ground. And we're asked the minimum, so how much does he need to just barely start lifting the monkey, or the crate of bananas off the ground so that he can break the crate and get some bananas out. So let's look at our free body diagram. So we have our monkey here. You can see my beautiful artistic abilities. Alright, there's our monkey. Okay, cool. I don't know what a monkey ears look like. Anyway, that's a terrible picture, but it's my monkey. And so he's holding onto the rope, and so what forces do we see acting on him? So we have the tension force going in the upward direction. We got his weight going in the downward direction. I'll use maybe a subscript M for my monkey. Alright, and then we know that there's some net resulting acceleration that he's experiencing going up. Okay, then I'm going to put a subscript C on there. The acceleration of M, because the acceleration of the monkey is not going to be the same acceleration as the crate, because the monkey is not attached or part of the rope. So then we also have the crate. Right? So the crate, what forces will it have acting on it? Well, it's going to have that same tension force acting up. It will also have a normal force acting up. And then it will have its weight force in the downward direction. And it too will have an acceleration, or it could have an acceleration, I should say, in the upward direction, but I'm going to use a subscript C so that I'm clear that it's a different acceleration from the monkey. So from here you should be able to set up some of the forces if you want, right? So you could look at the monkey. You could say, okay, the sum of the forces in the y direction is equal to ma for my monkey, and so we got T minus the mass of the monkey times G equals the mass of the monkey times the monkey's acceleration, right? Which is what we want to find. And you can do similarly for the crate, right? You can look at some of the forces in the y direction for the crate could be equal to ma as well. And so for the crate we got T plus the normal force minus the mass of the crate times gravity equals the mass of the crate times the crate's acceleration. So then the question is, in order to try to solve this problem, what do we need to determine? Well, we're trying to determine the minimum acceleration required for him to lift it off. So first of all, for him to lift it off, what is going to change here? Well, to me, what that's telling us is that our normal force must be equal to 0. In order for it to start lifting off, or the moment right before it's able to lift off, the normal force will go to 0. So to find the minimum acceleration, we want the normal force to be equal to 0, because again, we're trying to find when the acceleration of the monkey is at a minimum. Alright, so we want the normal force to be equal to 0, and in addition, if it's just barely about to start lifting off at that minimum condition, at that point the banana crate has yet to start accelerating upward, so we can also set the acceleration of our crate equal to 0. And so with that going to 0, now we can see, let's look at our equation a little closer and see. Tension, we don't know. Alright, and in fact, I believe it's what we're asked to solve for in part C of the problem. Okay, the acceleration of the monkey we do not know, and we're trying to determine as well. Alright, so what we can see is that we have two equations here with only the same two unknowns, and so we should be able to solve. Alright, so I'm going to leave things there and let you guys run with that as you try to solve. Sorry, I stopped the video for a moment there, but I just wanted to be clear that these assumptions that we're making here is to help you answer part A. so people don't get confused. Once you get to part B, things change slightly, right? At that point, the monkey has stopped his climbing and is just holding onto the rope. So he's affixed to part of the rope. So once you get to part B, you can see or understand that for part B and C, we're looking at a situation where the acceleration of the crate and the acceleration of the monkey will be together uniform but equal and in opposite directions. Okay, so keep that in mind. Your sum of your forces equations should look similar, alright, but just make sure that you're aware of those differences. Alright, good luck and let me know if you have additional questions.